This is Systems of Linear Inequalities, Part 1. A system of linear inequalities is a set of two or more linear inequalities in the same variables. So an example would be y is less than x plus 2 and y is greater than or equal to 2x minus 1. Together, these two are a set. They become our system of linear inequalities. The solution of a system of linear inequalities is an ordered pair that is a solution of each inequality in the system. When we graph our many ordered pairs that are a solution to our system of inequalities, we find these ordered pairs where the shaded regions overlap. So in this section here, we shaded below this line and above this line, so this red section right here is the overlap. That is our solution of our system of linear inequalities. Any ordered pair in this section is a solution of our system. The graph of a system of linear inequalities shows all of the solutions for the system. So the first thing we want to do is check some solutions of inequalities and see if they work. So here we have the ordered pair 3, 5, and I want to know if it works as a solution for this system. In order for it to work for the entire system, it must be true in both inequalities. So let's start with y is less than 2x. So for y, I'm plugging in 5, and for x, I'm plugging in 3. 2 times 3 gives us 6. 5 is less than 6 is actually a true statement. So let's move on to our next inequality. Y is greater than or equal to x plus 1. So y is 5, x is 3. 3 plus 1 is 4. 5 is greater than or equal to 4. Once again, this is true. Since it works for both inequalities in the system, 3, 5 is a solution. Let's test -2, 0. Once again, for it to be a solution, it needs to work for both inequalities in the system. So let's start with y is less than 2x. So y is going to be 0, x is going to be -2. So I get 0 is less than -4, which right away is not true. So this statement is false. I can test the next one, but I already know that -2, 0 will not be a solution for the system because it's got to be true for both inequalities, and I've already got a false. So I'm just doing this one basically for extra practice here. So -2 plus 1 gives me -1. 0 is greater or equal to -1, so I get true. But since 1 is false, this ordered pair is not a solution for the system. When I'm graphing a system of linear inequalities, I want to start by graphing each inequality in the same coordinate plane. Then I'm going to find the intersection of the half planes that are solutions of the inequalities, and that intersection is the graph of our system. It includes all the solutions of the system. So here we've got two inequalities that we want to graph. So when we go to graph them, if we have a less than or equals to sign or a greater than or equal to sign, we're going to use a solid line. If we have a greater than or less than sign, we're going to use a dashed line. Because the solid line tells us anything on that line is part of the solution, a dashed line that it is not. So when I go to graph these lines, I'm going to be thinking about just y equals 3 and y equals x minus 2. This one is going to be a solid line because I have the equals. This one is going to be dashed. So I'm going to start with y equals 3. So that's going to be the first line that I add to my graph. So y equals 3 is right here. So I'm going to actually find a test point that I can use for this line. And I'm going to pick my favorite, 0, 0. I can pick 0, 0 as long as it's not actually on the line, and it's not. It's down here. So I had y is less than or equal to 3. I'm going to put 0 in for y, and this is actually a true statement. 0 is less than or equal to 3. So in this case, 0, 0 works as a point, works as a solution. So everything down here is going to be shaded. Everything below the line. Now I'm going to graph y equals x minus 2. This one's going to be my dash line. So my y-intercept is down here at -2, and my slope is 1. So I'm going to draw in my dashed line. And I also need a test point for this line. And once again, I'm going to pick 0, 0. So now I'm testing my inequality y is greater than x minus 2. I get 0 is greater than -2, which is true. So 0, 0 works as a solution for this line also. 0, 0 is above my blue dashed line, so everything here is going to be shaded. Now my solutions are in this area right here. They're below this red line, but above the blue. Anywhere that my colors overlap, I find ordered pairs that are a solution to the system of inequalities. So this time, before I graph my lines, I want to put them in y equals mx plus b form. So I've got 2x plus y equals -1. If I want to put this in y equals mx plus b form, I'd have y equals -2x minus 1. So let's start with this line. So I have a y-intercept of -1 and a slope of -2. So down 2 over 1 or up 2 and back 1. And this is going to be a dashed line because I don't have the equals. All right, so as my test point, going to pick my favorite, 0, 0. So I'm testing, 2x plus y is less than -1. So 2 times 0 plus 0 is less than -1. I get 0 plus 0 is 0. And 0 is less than -1. False. So in this case, I want to shade the side that does not include 0, 0. So since 0, 0 is right here, I'm going to shade that side that's down and to the left. My second line was 2x plus y equals 3. If I want to write it in y equals mx plus b form, this is going to be y equals -2x plus 3. So I've got a y-intercept at 3 and a slope of -2. So down 2 over 1, down 2 over 1, down 2 over 1. And it's once again going to be a dashed line. And I'm going to pick my favorite test point, 0, 0. So I've got 2x plus y is greater than 3. So I put in my zeros for x and y, get 0 plus 0 is 0, and 0 is greater than 3. Oh, false. So once again, I want to shade the side of the red line that does not include 0, 0. That means I'm shading above and to the right. So in this case, I don't have any overlap in my shaded areas. So this system of inequalities actually has no solution. There are no ordered pairs that are a solution to both inequalities. Therefore, the system has no solution.